what do you think about an idea of storing hash keys as an int64 value? For example, Databricks uses XXHASH64 algorithm, which seems to be a lot faster than MD5, not to mention the potential increase of performance when joining on numerical columns versus string columns. And in all honesty, in the first part of the statement here, I have to agree. In the first part, right? So we discussed this. The thing is this: if you go for a smaller hash value, and MD5, for everybody who doesn't know, is using 128 bits. 128 bits is an issue because we have no int value for that, right? So we can't use, there's typically not an int 128 or super int or super big int or something available. That's a challenge. I believe, to be honest, there are some databases where they have a super big int, like an integer 128 bits. But it's not very common, and I wouldn't count on that essentially. And so you always have a problem, and typically you store a MD5 value or an SHA1 value as a binary value, like a raw 16 bytes, or 16 bytes? Yeah, 16 bytes, correct. Okay, I was just thinking. So raw 16 or raw 20 for SHA1. So that's all good. Some people try to use a UUID data type, which happens to be a 128-bit value binary form. But then there's no extra value of that, in my opinion, and you're limiting your hash functionalities to 128 bits. So that's why I wouldn't use it. I would always try to be as open as possible, because there's a slight chance that you might have to change from MD5 to SHA1, which means that if you used to use a UUID value, then you're stuck to the data, or you have to change this data type, or not just extend the size. That's why I would use the raw 16 or binary 16 data type essentially. Now, the advantage of using a smaller data type, and let's talk about those first. There's a lot of advantages actually. I fully agree with you. A smaller hash value is faster to calculate, so you can expect a drastic performance impact or performance gain when you use a int64 value like the XXHASH64 or some CSC64 value, for example. It will be much faster to generate, and there's statistics on that, which you will find. Best source for statistics on any hash algorithms is always the OpenSSL library on Linux or Unix systems. They publish benchmarks on how fast their algorithms are, and I believe they also have as a benchmark CSC64. I would expect it at least, and you will see there's a drastic difference between those values. So fully agreed on the generation, and I also fully agree on the join performance, because there's a difference, and there must be a difference if you're joining two columns with a larger data type versus smaller data types, right? Or multiple columns and so on. So what we see is that when you join 128 bits on each side, it must be slower than joining 64-bit values on both sides. So it's all great. I don't, not to mention potential increase of performance when joining on numerical columns versus string columns. I wouldn't store, well, you could, I would store actually the MD5 value as string columns as well. That's one thing. That's the other thing. So I prefer using string values instead of using binary for the data type, for the string data types, to be honest. So yeah, so that's another. But the reason for that is not because of the string versus numeric hash values. It's because of the size, right? When you store an MD5 as a string column, then it's not 16 bytes in binary, but 32 characters, 32 bytes, and that's a even bigger difference to your 8 bytes here on the int64. So it's 4 times, right? So for everybody who can do the math, that's 4 times, and the join performance will drop down. That's what it is. So all the disadvantages or all the advantages for the smaller int value. Now here comes one big issue though. In the book, we have one diagram. Apologies, first of all, the diagram. So the book in general, I would say, was good, but there's 2 major issues there, and we're looking at one issue now. Well, this is the corrected version from the editor. In the book, we have only 2 columns, I believe. We have the MD5 column and the SH1 column. But for MD5, it says number of 64-bit hash values. But I just said the MD5 function produces 128-bit hash values. So actually in the book, in the building a scalable data warehouse with data to a notebook with me and Dan, we don't have MD5 in the book essentially. We use this column here and have the wrong label on it. It's a CSC64 statistics essentially with 64-bit values. That's this column. That's what we have in the book. And the SH1 column, that column is missing. Okay, so that's the ND5 comes completely missing. All right, so when we look at this here, how do we read this? So let's say you're going for a CSC 32 hash value. In this case, your hash functionality provides you 32 bits essentially, right? The problem with that is, yes, it will be even faster than your int64 approach with the XXHASH64 on Databricks. But the problem is, when you load 10 rows into a hub, or 10 business keys into the hub, or 10 relationships into the link, you will have a chance for a collision of 1 in 100 million. Sounds small, right? I don't know. When you load roughly 10,000 records into your hub or link, you have a chance in 1 in 100. That's a much bigger number. So to get a feeling for these numbers, in its training, we go through this actually in more detail. The odds of a full house in poker, I don't play poker, but I have multiple full houses. So that's 1 in 693. No surprise that Michael Schimger has a full house in poker. The odds of 4 of a kind in poker is 1 in 4,164. I had less 4 of a kinds, but I had some. So again, no surprise. The odds of being struck by lightning, that's 1 in 576,000 roughly. This one also means you survive, I believe. You're not dying from that. That's a low number, but actually it's such a high number that newspapers don't report on this. This happens all the time and nobody cares. Because, I mean, there's some countermeasures for that, right? Don't go below the tree, that kind of stuff. If it happens to be the field, lay down in the field. Yes, it's wet. It's not nice, but it's the best spot you can get. Or maybe that's the best spot. So don't sit below the tree. Just saying, right? Then the odds of winning a 6 out of 49 lottery is roughly 1 in 40 million. I don't play the lottery for reasons. I think it's double taxation, to be honest. I don't even like to pay the first part of the taxes. So, and in Germany, it's actually a 7 out of 49 lottery, which is even worse. So but you hear sometimes people winning the lottery. But it's newsworthy sometimes if they win the jackpot, that kind of stuff, right? But it also happens quite often. So it's 1 in 40 million roughly. Odds of dying in a shark attack. Here's the death now. This one is just struck by lightning. Here you get bitten and die. The chance is 1 in 300 million. And that's where I say, well, I don't care. I was swimming in shark areas and I didn't care because the chances were very low, at least for my feeling, right? So 1 in 300 million, that's fine. Odds of a meteor landing on your data center, it's 1 in 182 trillion. If that's a problem for you, well, first of all, the original example said the odds of a meteor hitting you. Because the data center has a larger surface. We got criticized for this example here because the data center has a larger surface, and I fully agree. So the chance is higher. Okay, get it. Granted. So, but if this is a challenge for you, and if you don't want to take this risk, then I would stay in your bunker. Seriously, that's what I would do in your case, because that's your minimum lifetime risk if you are on an empty globe. Because your chance of getting killed by a bear or by an idiot in a car and you on a sidewalk, right, and this guy hits you or whatever, is much, much higher, to be honest. I don't want to scare you guys, right? So you can go out. It's a chance. So, but it's much, much bigger than this one, to be honest. This one here means that you're on an empty globe, essentially, right? Well, your lifetime risk at least. So what do we do with this? The thing is this: when you go for CSC64, the chances improve essentially. So you can essentially load more data into the same target AD with the same risk essentially. So instead of loading 10 rows, you can now load 607,000 rows into the same AD and have a chance 100 million, roughly my low risk 1 in 200 million. I don't care anymore, right? So I would as long as there's no shark in the water, I would go into the water, to be honest. I don't care. But then when you look at the number of 128-bit values, then you see all of a sudden it just goes up, right? So 2.61 times 10 to the power 15. I have no freaking idea what number this is, to be honest. I don't know. So it's a large number, that's for sure. And I don't need to load this in most systems, so I'm much more below here. And then I'm maybe loading 2.61 times 10 to the power of 12. That should be trillions of rows in English. Trillions of rows. And that's a very low chance for a collision. And then I feel very comfortable because I'm leaving the house after I'm done here and what else. So that's all good. And and that's the reason why we use a higher hash function with more bits, because it doesn't matter how you calculate these bits. That's your risk, right? So no matter if you're using CSC64, which is not a cryptographic hash, or XXHASH64. I'm not sure if that's a cryptographic hash. I doubt it, because it wouldn't be secure anyway, because the bit size is too small for cryptographic approaches as well. So I wouldn't use it, not for security and not for data vault, because the chance for collision would be way too high. So yes, I would love to use a smaller hash value, but when I look at the potential risk here, it would limit my solution to very artificial solutions which we are not building at universities these days, right? Even in educational settings, we're using much larger data sets to give them a better feeling on how to process large data sets. So if you have, let's say, 2 million customers, yeah, good luck with that, because every 10th million customer in the future, I mean, if you have 2 million customers already, I can see the future where you have 10 million customers as well, even by either by organic growth or by purchase acquisitions. So there's a chance. And if you have, let's say, 60 million taxpayers, 1 in 10,000 will not pay taxes. Well, I like it, but I'm just a taxpayer. If you're the government, that's not good. So that's the thing, right? So that can't be a good solution here with CSC64 or any 64-bit value, because that's the problem here. It's the size of your result. You really want to have at least 128 bits, and if you happen to have a lot of data volume, I mean, whatever that means, right? Then you might even have to consider SHA-1. But on the other hand, I don't see a value from a statistical analysis here or statistical standpoint here to use SHA-2. That's just a pain typically. You don't want to use that one, but those options here, because of bit size and the availability of functions, that's your typical choices. You could use something else in MD5. So if you want to use a faster algorithm, there are faster algorithms than MD5 that produce at least 128 bits. That could be a choice. But then the only challenge is this functionality must be available in your systems. That's the other point. The XX hash value. I didn't go into too much detail, to be honest, because the whole idea was killed when I saw it's a 64-bit value, right? Based on the name. But the question now, my next question would be, let's say it would be a acceptable solution for the bit size. My next question would be, is it available on other platforms than Databricks? In Python, maybe, and maybe in Snowflake, right? And so on, in other databases, because you might want to build a solution that spans across Databricks into on-premise databases, into some cloud database, some other cloud databases, and so on, right? And or Redis cache and so on. So for this scenario, I need to be able to calculate the hash function, the hash values independently from Databricks on Snowflake, on Python, and so on, right? And that's the next question. Is this hash function available? And if not, don't use it, because then you're limiting your solution to Databricks. That's what I wouldn't do as well. And that's the beauty of these standard algorithms, MD5, SH1. Those have been cryptographic hash functions that everybody was using. They're inside your CPU instruction set. So the CPU knows how to calculate blocks of MD5 or blocks of SH1, for example. It's widely available. All the libraries support it, all the, maybe not all, but most of the database engines support it, and so on. And that's why we use these MD5 SH1 algorithms, because they're standardized. Everybody knows them, everybody knows how to calculate them, and they're even easy to reproduce as well. So that's the reasons for that. Yeah, so that's a killer. That's, sorry, yes, smaller might be nicer, faster, and so on, but I don't want to have this hash collision. That's why I'm not using it. And that's why I would actually recommend against the use, even at educational settings. If you have a question like this, use this link, the link that points to the form, where you can submit your questions essentially at sfr.ee/dbfriday. You can also submit your questions just below the YouTube video. Any question, we just pick it up from there. And get your free copy of the Databricks handbook, written by a colleague of mine, Hanan. And you can download this book directly as a PDF or something, or as a online book essentially, with the right QR code. And you can also order a hard copy from us. Thanks, guys. See you next Friday.